So guys, today we are going to discuss about the association rule learning. Okay, we are going to discuss about association rule learning. What exactly this association rule learning refers to? See, generally this association rule learning quite implemented in the areas of the retail market. Okay, we will generally work with this association rule learning in the areas of the retail or supermarket kind of stuff. So this rule based machine learning will be used in order to understand the interests or relations towards the interest. I mean, like relation between different interests. The people is going to buy a milk packet from a supermarket. When they are buying the milk packet, are they going to buy a coffee powder or not? The linked interest. Okay, so it is intended that identifying these kind of rules will create some measures for us. Based upon this, we can clearly observe and we can identify the sales. Understand? So here, let us try understanding for 5 particular transactional data, how it is going ahead in a supermarket. Okay. Now, what I'm gonna do, I'm trying to open an Excel sheet. So, and I just wanted to give you more awareness about this particular example using this Excel sheet. So there was a transaction happened. This is the transaction ID, and there are multiple things which are going to get. So this is how the this is how the table is there existing for us. So now this data that we are trying to analyze, here we could understand very clearly that there are different items here. So each and every item that I'm going to consider them as I1, comma, I2, comma, I3, something, etc. IN. Okay. I1, I2, I3, IN. So here, by looking at the given data, transactional data, we understood the first transaction made by one customer has bought milk and bread, and the second transaction which was made by another customer have purchased the butter, and the next customer who purchased the beer and coffee. Okay, and the next customer who purchased the milk, bread and butter. Okay, and the fifth customer who purchased the bread. Now we can clearly understand whoever purchasing the milk are tend towards buying the bread together. Okay, now these sort of stuff that we could clearly understand from the given transactions more clearly with this association rule learning kind of stuff. So we have two different types of algorithms in the association rule learning. One is a priori and another one is eclat. So now coming to this one, so if at all if I'm going to say that the I represents all the items inside which where I could say that D means a database which is consisting all the transactions like T1 comma T2 comma T3 etc until Tn. Okay, so guys, now for each transaction in the database D will have a unique transaction ID, okay, and it will contain a subset of items in the I. Means for every transaction you can see a subset of I. Means not the entire I can say, okay. So subset of the I. So I can say, so the each and every database transaction will have a subset of, so every rule will be generally with will be existing with the two different sets. Okay, let us say an x and y, two different item sets x and y. So here generally we generally do call in statistical terms these item sets x comma y. One is x, which is generally antecedents, otherwise left-handed side. Another one is y, consequent, which is right-hand side. Okay. Okay. So here, all these set of items for a transaction, and the items list we have milk, bread, butter, beer, and coffee are there everything within a database, but we are clearly represented for each and every transaction. There are only couple of items. So the butter and the bread is always correlated with the milk. Why? Because whenever someone buy the milk, it is understood that they are buying the butter. Okay, something like that. So this is a very small example to understand the association rule about the 5 transactions, but in real time we will be having thousands of transactions like this. Okay, so based upon this one, we should understand something called a lift. What do you mean by a lift? Lift is a one such kind of rule in the background to understand the see, we have to understand three things here. We will be literally, in the background we will have three technical terms to define this algorithms. One is support, confidence, and lift. Okay, we need to measure generally these three things for finalizing. Okay, okay, which product the customers are buying in parallel with another product, something like that. So support is none other than it's an indication how frequently the item appears in a data set. Okay, so for example, in our data set you can see that beer and coffee Okay, it is have a support of 1. See, beer and coffee has a support of 1 out of 5 transactions, which is going to be zero point 0.2. Okay, so hence it occurs 20% of all the transactions. So this is having a support. Okay, and the next one, confidence. Coming to the confidence, it is an indication we can observe that how often a rule can be found to be true. Understand? We can clearly understand how a rule can be understood to be true. So hence, let us take an example, the same example. The butter and the bread. Okay. The rule butter and bread refers to milk. Means whoever that they are buying the butter and bread together, they are buying milk. For sure. Otherwise, milk and bread, the whoever that they are buying milk and bread, they are not buying the butter in one transaction. But in another transaction, they are buying it. So let us keep that one apart. Whenever someone is buying bread and butter, they are buying milk. So it has a confidence of zero point 0.2 divided by 0.2 is equal to 1. So this means that 100% of the transactions containing butter and bread, the rule is correct. Means 100% of the times a customer who is buying the butter and bread, they are also buying the milk for sure. Okay. In the same way, we have one more thing called lift. Okay. So for the milk and bread, whoever buying milk and bread, they are buying butter. Okay. If we think this particular concept, you could observe that this kind of example will have a lift of zero point 0.2. Why? Because it's a transaction into divided by 0.4 into 0.4, which could be 1.25. How I made it this one? So guys, this is none other than the observed stuff related to this lift between the antecedents and the consequents. Whatever that we find the left hand side are the antecedents, and whatever that we find right hand side is the consequence. So as a part of this one, if a rule has a lift of 1, we can clearly say that the probability of occurrence of the antecedent and that of the consequent are independent of each other. Means whenever that these two different events are independent of each other, then there is no rule can be understood which is involving these two events. For example, if it is more than 1, means if the lift is greater than 1, then we can understand the degree to which these two occurrences are dependent on one another. If it is less than 1, they are substitute to each other, means that the presence of one item has a negative effect rather than saying a positive effect. Okay. So generally these kind of stuff that we can clearly understand from the association rule learning. So in the association rule learning, we will have something called two different types of algorithms. One is the a priori algorithm and another one is the eclat algorithm. Okay, a priori algorithm, and another one is eclat algorithm. Okay, so coming to the a priori algorithm, this will generally use a breadth first search strategy. Let me write down this one. Breadth first search strategy. See, this is a strategy where it will go ahead in a breadth wise to count the support of item sets. Okay, coming to the eclat, eclat is generally called as equivalence class transformation. Okay, now this is something called a depth first. Depth first search algorithm. Okay, so this is suitable for the parallel execution or enhancing for the existing stuff and all kind of things. So now let us try understanding these two algorithms by execution. Okay, so now let me open something in relevance with this one, association rule learning. Royal See, we have something called market basket optimization. So now let us take a look at this one. See, we have imported as usual the libraries NumPy, Matplotlib and the Pandas. Okay, done, imported. Now I have a data set which is called the so-called market basket optimization. See, in the market basket optimization stuff, we have something related with, uh, we have knowledge programs. So here I have market basket. See, this is having nothing but how the different products have been bought in a one particular shopping mall. Okay. Okay. Now, in order to capture this part, I'm going to use this one. I'm going to set the complete. Okay. Now, we are going to execute this part. We are reading this particular program. So done. For I in range 0 to 7501, the transactions dot append, all the values is going to capture. You can clearly observe this in this market. How many columns are there? 20. Okay. How many rows are there? So the total number of rows are around 7,000 actually. So hence I'm not going to filter them out here. So this is how that I just wanted to go for entire all the data set values. Okay. So now from a priori, okay, I'm trying to import a priori algorithm, and rules for the a priori algorithm, etc. Transactions are going to be loaded here. Minimum support is 0.003, minimum confidence is 0.2, and minimum lift is 3, and minimum length is 2. This is how that I just wanted to understand. This is my basic requirement regarding the confidence, support, and the lift. Okay, so now I'm executing this part. Looks like I don't have the a priori, library. So let me just go ahead and try to install the a priori library. Now it was imported. Let me like execute this one rules. Let me go ahead with the rules. So all these results, whatever that we have got over here, is a complete list after it has calculated the minimum support and the confidence and the respective lift. Okay, did you all understand so far, guys? Are you good so far? You can also get identifying the individual item by giving this individual result. And we can also do the more programming by displaying in a different way of the results. You could see that this is going to display you something like a JSON format. Okay, you can just cut short them and you can just make them in a one particular single line. Okay, so you could see the confidence for the item like chicken and the light cream, how much is the support and all order statistics kind of stuff. Okay, based upon this one, we can always evaluate the best products which can be loaded with the best inventory for a one particular company. Okay, so guys, this is what all about the a priori like association rule learning. Tomorrow we will discuss about the reinforcement learning, and also apart from reinforcement learning, we will discuss about the model selection, and we have one more algorithm we need to check. reinforcement learning, dimensionality reduction. Okay, implementing the PCA, principal component analysis, and linear discriminant analysis needs to be done. Okay, so we will do that part in the tomorrow session. Okay, so that we will be working on the NLP and the image recognition on this Sunday. Okay, are you good so far, guys? Any questions? Anusha, Narayana, Ram Dinesh, Sunil Kumar, Suresh. Okay, guys, then I take it as no questions. Like, if you do have any questions, please do ask me in the next immediate session. See, that also works in the same way, Ram Dinesh. Okay, I will send you a program related to the ECLAT. Okay, I will share the program related to the ECLAT. You can just try it out as a homework or an exercise. Okay, Ram Dinesh. Same thing, there is no difference at all. You're going to use the ECLAT as a function actually. With the, I mean, generally a priori is a famous one, okay, which we generally go ahead. Okay, even ECLAT you can use it. You can go ahead with the ECLAT also. I will share the programs. See, this taking the values of the support, generally I have showed you like in this. For example, the support it is going to be, see, we cannot make certain certain point of support. I need this support, I need this confidence level, I need this lift. It's not something like that. Based upon the requirement for the store or based upon the, like how you want that to be. Like means like based upon the transaction it is happening and based upon the products that you are going to choose. Why? Because for every individual product, Sunil, there is a different see, even though I set the, see, let me show you this one here. I set some, minimum support. This is a minimum. So if you can take a look at this one, in the given example, the support is 0.004, and here it is the confidence is 0.29, where it is minimum is zero point 0.2. Okay, so generally, these are the values that we could go ahead with that. Like, and also lift is 4.6. Generally, I have just defined the lift which is greater than 1. Everyone will rely on the lift which is greater than 1 only. Okay. So here the minimum lift where I have chosen is 3. Means the good relation. If you want to increase, you can increase also. Okay, I wanted to increase this minimum confidence to 5. So some people will, there is no benchmark to select this support and confidence and lift levels, understand? So you can prefer more also. If I'm going to prefer more, let me say I want the minimum lift as 5. Okay, and also I want something 0.5, and here I want something minimum support as some 5. Okay, now let me execute. See, the index is okay, out of range. It looks like. Now let me execute this. I see no nothing. So let me just decrease this part. Okay. Now let me execute. I see nothing. So minimum confidence, I'm going to get this decreased. Okay. What is the confidence level? I just want it as to 3.3, and I just want the minimum lift to be 4. Even it is not showing me the best wing. So let me just make this one as 0.2. Even still it is no. So minimum lift, I just want to decrease it to 3. I'm sorry, actually it might have given us the results, but I did not check the results, guys. I'm sorry. So now if I'm going to, I might got the results. Let me check like this. This is how that we can get the results over here. So now you have got the results like this. So lift I'm going to provide as I told you. Let me give the lift as some 5, and even minimum confidence is 5, and also minimum support is 5. Now let me list the results. So see, this much of results are not there actually for this kind of support and all stuff. So I want to take the minimum support, some 3. Even now I don't have it. 4. Let me decrease this to 4. See, generally Tableau will be used only for the visualization purposes. Okay. So you can on whatever the data that you are doing the analyze. Okay, you can make use of the R code in the Tableau. Otherwise, you can make the visualizations in the Tableau itself directly by loading the data into Tableau. Okay. Okay, Suresh. Guys, in the evening, there are some free Tableau sessions are going on. If you can have the time, you can try connecting the evening sessions between 8 to 9. Suresh and all of you guys, between 8 to 9 in the evening every day. Not exactly, Sunil. Basically, here I'm not much interested in this particular store related details. But for example, if you want to maintain or understand, okay, it is not all based upon the observing the data set. We have to select the support confidence list. For example, you have more sales related to one product. You wanted to correlate or you need to understand based upon this. So you are asking the benchmark values for the minimum support and confidence and the lift, right? I can tell you the best minimum support and the confidence level and the lift always, if you take the minimum lift as 3 is going to be always average kind of stuff that you can try to prefer. Why? Because when you are going to increase the lift, what happens, the most frequent products that you are going to come under. When you are going to minimize the lift, what happens, you are going to come up with a large number of products that you are going to find out in the, see, whatever the products that you are going to find out here, you need to bring them to the store, right or wrong. You need to increase the inventory. So based upon that part, I could say the average benchmark of this particular support confidence and the lift is 0.03 and zero point 0.3, and minimum lift is 3 as per me. Okay, you could go ahead something like that. And the most better confidence will comes up, you know like zero point 0.4 zero point 0.5 kind of stuff. Okay, but I have selected very minimal here. Okay, in order to increase my inventory based upon the results that I have got it through the a priori algorithm. Okay guys, we will meet again tomorrow, and we will discuss few more concepts as I told you. Thank you all of you. Bye.